In previous videos, we covered how we would find the correlation coefficient and how we would find the least squares regression equation for a given set of data. In the graph shown below, we see that we've got our data values. And based on these data values, least squares regression line has been calculated, and we can see the line graphed here. Now, this additional portion that you see on the graph shows that as we're outside the range of our x values, we can't assume the trend continues. So keep in mind this least squares regression line can only be a good predictor if we're within the range of data values given by our scatter plot. Although a straight line by itself can continue forever, its usefulness in predicting fails outside the range of data values. So our key reminder, do not use the least squares regression line to make predictions for x values that are outside the range of data given. So in this next example, we have a sample of adults was studied to determine the relationship between education level and income. The least squares regression line for predicting income from education level was computed to be y hat is 2812 plus 3375 times x, where x is the number of years of education, and y hat, that will be the predicted annual income. The number of years of education among the people in the sample range from 8 to 18, so my x values range from the lowest end to 8 up to the highest end of 18 in the sample. If possible, use the least squares regression line to predict the annual income of a person with 12 years of education. When they say if possible, the if possible is are we within the range of data values? Well, 12 is within 8 to 18, so it is possible to use the least squares regression line to make a prediction about this value. All we have to do is now we'll say x is 12. Then in our least squares regression equation, we have the predicted income y hat is 2812 plus 3375 times our x value of 12 will give us a predicted annual income. Here we'll type this into the calculator and we get 43,312. Now let's look at the next one. If possible, use the least squares regression line to predict the annual income of a person with 6 years of education. If not, explain why not. So do you think we could do something similar in this example? Hopefully that gave you a little pause because 6 is not in this range. 6 is before the lowest value in our data set of 8. So it lies outside the range, so the least squares regression line does not make prediction for values outside of the range. So we'll mention that there. Not possible because the x value of 6 is outside the data range. Of 8 to 18. So our next topic is that of residuals. So whenever we talk about residuals, we have a scatter plot given, we have a least squares regression line calculated and graphed, and if we're asked to find the residual, that is the difference between the actual value and the predicted value. So what you can see here in this graph is for the x value here, this is the actual value that I'm shading currently. But notice, based on the least squares regression line, this was the predicted value. This entire difference, this y distance, is what the residual is. And the residual can always be calculated if you take the actual value and subtract the predicted. Now keep in mind, because of this pattern, if your actual value is above the line, the residual will be positive. If the actual value is below the line, for instance, this data point, the actual value is below the line, so this residual will be negative. So when we're asked to compute this residual, all I need to do is remember the formula. Residual is equal to actual minus predicted. Now they gave us specifically this point, which was nicely marked in the graph. The actual y value is 426 minus the predicted y value of 413.6. When we type that in the calculator, we get a residual of 12.4. So keep in mind residual actual minus predicted y value. Our final topic of this video is the coefficient of determination, which we indicate with r squared. So the coefficient of determination, and really quick before we go forward, where have we seen r before? Remember, r is the correlation coefficient that we learned to calculate earlier. So this coefficient of determination is just that correlation coefficient r squared. So the coefficient of determination is the most often used quantity that measures how well the least squared regression line fits the data. So it tells us how good this least squared regression line is in fitting our data set. Now, how do we determine whether it's a good fit or not? The closer the coefficient of determination r squared is to 1, the closer the predictions are. So it's a better fit if our r squared is closer to 1. And the way that we need to think about r squared is that it measures the proportion of the total variation that is explained by the least squared regression line. So how would you find r squared? Step 1, you would find the correlation coefficient r. Now, we went through how to find r in a previous video, so if you need a refresher of that, go back early in our notes or watch the previous video about that. But once you find the value r, then all you have to do is square r. And remember, squaring is multiplying it by itself, so that's r times r. That is our r squared. So in this next example, we're actually told our value of r. We don't have to go through the additional process of calculating it. Again, if you want to see how to do that, go to a previous video. And we're asked, what is the coefficient of determination? We would just take our r value and square it. So this is 0.9005918, and we'll square that. Now this, when we round to the first few decimal places, is 0.811065559. So that'd be our answer. Now this particular problem was really quick because we already had r given to us. Remember, if you're not given r and you're instead given a table of values, your first step is to find r following the procedure that we've seen in a previous video. And then once you get r, your final step is to just square that value, and then you'll get your coefficient of determination. Now, part B says how much of the variation in selling price is explained by the least squares regression line. This goes back to this statement. The coefficient of determination r squared measures the proportion. Remember, proportion is part out of whole. We can translate that into a percentage of the total variation that is explained by the least squared regression line. So how much variation is explained by the least squared regression line? That's exactly here. R squared is that proportion. So this proportion explains the amount of variation the selling price is explained by the least squared regression line. So all I have to do is record r squared is about this value. Now currently this is a proportion, a part out of a whole. In terms of making this easier to think about, we're going to change this into a percentage. We know we changed the percentage by moving the decimal place twice. So that gives me 81.106559, or about 81.1% of variation in selling price is explained by the least squared regression line. So just recapping, this new quantity that we just discussed, r squared coefficient of determination, it is based on a previous quantity, r, the correlation coefficient. So before you go to the homework problems about the coefficient of determination, go back in your notes and make sure you're confident how you would find r first, because then all you have to do to find the coefficient of determination is just square that value once you found it. So as always, if you have questions, feel free to contact me via our campus communication, and I'll do my best to help you.